Welcome to our presentation on organizing data. Today, we'll explore various methods to effectively organize and visualize data. We'll cover key topics including notation, stem and leaf displays, dot plots, histograms, and both qualitative and multivariate data. In statistics, notation typically refers to the number of observations or elements in a subgroup of a dataset. For example, the sample size is often denoted by n. When dealing with data sets, individual observations are denoted by x1, x2, x3, and so on. The first observation is x1, the second is x2, and so forth. A stem and leaf plot is a graphical tool used to organize and display numerical data by splitting each data point into a stem and a leaf. In a stem and leaf plot, data is listed from least to greatest to ensure no data element is missed. For example, a score of 83 would have a stem of 8 and a leaf of 3. To construct a stem and leaf display, list the stem values in a vertical column and place the leaves to the right of each stem. Stem and leaf displays provide insights into the data, such as typical values, data spread, gaps, symmetry, peaks, and outliers. Let's look at an example with volleyball scores. We can construct a stem and leaf plot to represent the data set of points scored by team members. Consider a set of test scores out of 100. We can create a stem and leaf plot to visually represent this data set. A dot plot is a simple graphical display used to visualize the distribution of small to moderate-sized datasets, with each data point represented by a dot. Dot plots provide an attractive summary of numerical data, especially when the data set is small or has few distinct values. Dot plots use a number line to show how frequently numerical data appears, with each dot representing one observation. Here's an example of a dot plot showing the frequency of high temperatures recorded over a period of time. Consider the scores from a quiz. We can use a dot plot to represent the number of students who achieved each score. Let's look at another example with test scores. A dot plot can help us visualize the distribution of scores among students. A histogram is a graphical representation of numerical data distribution, where each bar represents a range of possible values. Numerical data can be discrete or continuous. Discrete data has specific values, while continuous data can take any value within a range. Histograms for continuous data display distributions with contiguous bars, showing data that can take any value within a range. Histograms for discrete data show distributions with separate bars for distinct values, such as counting the number of students who scored specific grades. The relative frequency of a value is the fraction or proportion of times the value occurs. For example, if you have test scores for 100 students and 20 of them scored between 80-90, the relative frequency for the 80-90 bin would be 20/100ths or 20%. To create a histogram graph, use the table as a guide. The table shows intervals and their corresponding frequencies, which can be plotted to visualize the distribution of data. This table represents a frequency distribution for the number of hits per team per game for all 9-inning games played between 1989 and 1993. It helps in understanding how often different numbers of hits occurred. The histogram in the figure rises smoothly to a single peak and then declines, showing a slight positive skew. This means the histogram extends more on the right side, indicating larger values are more frequent. From the tabulated information or the histogram itself, we can determine the proportion of games with at most 2 hits by summing the relative frequencies for 0, 1, and 2 hits, which equals 0.0155. Similarly, we can calculate the proportion of games with between 5 and 10 hits by summing the relative frequencies for that range, resulting in 0.6361. This means roughly 64% of these games had between 5 and 10 hits. Qualitative data refers to non-numerical information that describes characteristics or qualities. It includes data such as names, labels, or categories, like colors of cars, customer opinions, or types of cuisine. Multivariate data involves more than 2 variables and is used to analyze relationships between different variables. It can be both qualitative and quantitative, such as in health studies or weather data analysis.